Today we are going to see classification of thermodynamic processes. Classification of thermodynamic processes. See here, thermodynamic state can be described by its pressure denoted by P, volume denoted by V, and temperature denoted by T. That means P, V and T. These are three main variables in thermodynamics. Now, here we consider by keeping any one of this variable constant and we vary the two variables, then we get different thermodynamic processes or thermodynamic changes, and by depending on these we classify the thermodynamic processes. Now here we consider first, that is reversible and irreversible processes. This is the first type, reversible and irreversible process. Now here first we will see what is meant by irreversible process. Here the process which do not restore its initial state. You know, there are two states, initial state and final state. Suppose any system is in initial state and it goes to final state, and if in a reverse way, if the initial state does not restore, then that type of process is called as irreversible process. For example, we consider here that is a puncturing of a tube or burning of a candle. These are irreversible processes. Irreversible. We have studied that is irreversible processes. Now we will see reversible process. The process in which there is restoration of the initial state of system, restoration of initial state, and here restoration is not possible. Restoration not possible in case of irreversible process, but in case of reversible process there is a restoration of initial stage or initial state. For example, we consider here melting of ice. That means ice converted into water, and freezing of water. These are reversible processes. That means whenever we give heat to the ice, it melts, converts into water, and if we place that water into the fridge, then there is creation of ice. We consider boiling of water, condensation of steam. That means whenever water is boiled, it gets converted into steam, and whenever we take some heat from, or we cool the steam, then it converts into water. These are some reversible process. Now here we consider that is a path traced in case of reversible process is the same in both forward and reverse direction. Suppose we consider this is the PV diagram. We consider pressure on y-axis, volume on x-axis, and suppose A be the initial state and B be the final state, and suppose this is the curve. Then suppose this Pi or Pf, we can consider here Pi and Pf. This is Pi, this is Pf, this is Vi, and this is Vf. Then here, when system at initial state A having pressure Pi, volume Vi, then it goes to state B having pressure Pf and volume Vf from A to B. And whenever it comes from B to A, it traces the same graph for reversible process. And this is for reversible. And for irreversible, we consider suppose PV diagram. This is PV diagram, pressure on y-axis, volume on x-axis. Suppose this is A and this is B. Suppose this is the path A to B. But from B to A, there is a different path. That means, suppose this is Pi, this is Pf, this is Vi, and this is Vf. Then here system when state goes from A to B, this is one path. And when it comes from B to A, there is another path. An irreversible process here that cannot be retraced in same direction. The path of irreversible process is not same. Now here this is due to the permanent loss of energy. This is due to the permanent loss of energy, and permanent loss because there is a friction causes, that is friction, or we consider any forces, dissipative forces, we call dissipative forces, and due to that it cannot retrace the same path. Now here we consider causes of irreversibility. Causes of irreversibility. What are the causes? Cause of irreversibility. What are the causes of irreversibility? First, many processes such as free expansion or an explosive chemical reaction takes the system to non-equilibrium state. That means system goes to non-equilibrium state. This is the first cause. And second, most processes involve friction, viscosity, and some dissipative forces. And due to that forces, there is loss of energy. These are some causes of irreversibility. Now, here in this thermodynamic process, we assume some things. That is assumptions in case of the discussion. Assumptions for discussing the thermodynamic process. That means first, majority of the thermodynamic processes are reversible. Majority processes are reversible. This is first assumption, or we call it as a quasi-static in nature. This is first assumption. Then second, we consider the system involved in all processes is ideal gas enclosed in a cylinder. Ideal gas enclosed in a cylinder having movable, then frictionless and massless piston, and also that is walls of the cylinder. Walls are good conductors for isothermal, because for isothermal process, walls are good conductor for isothermal process, and thermally insulating thermally insulating for adiabatic process. These are the three assumptions. That means majority processes are reversible and quasi-static in nature. Now second is we consider here ideal gas enclosed in a cylinder having movable, frictionless and massless piston and walls. We consider for isothermal good conductors, and for adiabatic thermal insulating. And third one, that is ideal gas equation. Ideal gas equation is applicable to the system. Applicable to a system. These are some assumptions. That is three assumptions in case of this isothermal processes. Now we consider next one, that is a second type of process. Suppose isothermal process. Isothermal process. Isothermal process. Here a process in which change in pressure and volume takes place at constant temperature. Temperature is constant, so we call it as a isothermal process or isothermal change, and for such system we consider delta T is equal to 0. This is constant temperature process. For example, we consider here melting of ice, or we consider boiling of water. Melting of ice and boiling of water is here. Suppose melting of ice, that means when you up to which ice cannot completely melts, up to that if we supply the heat to the ice, then its temperature remains constant. Or whenever water reaches to 100 degrees centigrade, then it starts boiling. Whenever it completely converts into the steam, at this temperature, constant temperature, it completely converts into the steam. This is the example of isothermal process. Now we consider thermodynamics. Thermodynamics of isothermal process. Thermodynamics of isothermal process. We have to see some mathematical relations. Here Boyle's law is applied. We can write that is Boyle's law means PV equal to constant. Suppose this is equation number 1. Now suppose we consider PI, VI and PF, VF, the pressures and volumes at initial and final state. Now we write here work done. Work done is equal to dW. We can write here PdV. Suppose this is equation number 2. And therefore we write here W is equal to integration VI to VF PdV. Suppose this is equation number 3. Or we can write here, but we know PV equal to nRT. PV equal to nRT, and therefore P is equal to, we write here, nRT upon V. This is equation number 4. Putting this equation 4 in equation 3, we get W is equal to nRT, value of P, nRT integration VI to VF dV upon V. And therefore we write here W is equal to, work done is equal to nRT log, nRT into log to the base E VF upon VI. We write this is equation number 5, this is equation number 6. Now from first law of thermodynamics, W is equal to Q. You write from first law we write W is equal to Q, and therefore we write Q is equal to W is equal to nRT log to the base E VF upon VI. VF upon Vi. Suppose we write here. This is equation number 5 and this is equation number 6. And if we plot the graph, suppose we plot this graph of P versus V. Suppose this is the graph from A to B. Suppose this is Pi, this is Pf, this is Vi, and this is Vf. This is a PV diagram. We call it as a PV diagram. And this graph is at constant temperature. So we call it as a isothermal curve. Or this change from A to B or from B to A, we call it as a isothermal change. This is all about isothermal process, and this curve we call it as a isothermal curve, or we also called it as a isotherm. I hope you all understand this. Now we are going to see third type of process in next lecture. I hope you all understand this. Thank you.